This is problem number 57 on page 461. And it looked pretty interesting. I've never done it before, but I worked it out. From data on the Calabrian Mafia in table 10.12, it is possible to study whether mafia groups, or coscas, choose their leaders such that the age of the leader is related to the mean age of the members of the cosca, of the group. Analyze the relationship between the two variables. Well, it's pretty interesting, but apparently it was published. I guess I didn't know the mafia kept records like that and shared them with people. But anyway, so they have these 9 groups here, and I went through and figured out the regression analysis on my calculator. Now the mean age of the members was 35.6 years. The mean age for the chiefs is 43.4 years. So these guys are about 8 years older on average than the members. And, oops, excuse me. So I did the regression analysis, and the age of chief, let me just call it chief, according to regression analysis, is minus 51.2 plus 2.66 times the age of the members. So for example, if the age of the members averaged to be, say, 40 years, say a particular group, the average member's age was 40 years, if I put 40 here, then I would calculate this. Let's see, 2.66 times 40 minus 51.2. That means the average chief would be 55.2 years old. Okay, so there would be a 15-year difference if the members averaged 40 and the chief was 55 years old. What if this was 30 instead? Let's check that out. So I'm hitting either side of this mean here. So if this was 30 years old, then how old would you expect the chief to be? That'd be a pretty young group. And so same calculation, except I'll plug in 30 for the members, and I've got 28.6. So in that case, the chief would actually be younger. Okay. The youngest group is, actually the Ruga group is 31 years old, and their chief is 29 years old, so that's actually in the ballpark with our regression here. And then there is a group that actually does the Nerta Romeo group. The average age of members is 40, and their chief is 67, which was quite a bit older than what we predicted. So, you know, there's the random variation you would expect in any set of data. So what do they want us to do with this? It says analyze the relationship between the two variables. Okay, well, that's part of the analysis is to come up with a regression line, and if you're in my class, I don't expect you to calculate the regression line. I don't think it's really a key component of this course to have to do that. But I did it for you there, and the the correlation coefficient, I need to get it back on my calculator here. The correlation coefficient of this data was 0.70. Alright, so that means that r squared would be 0.49. That means that 49% of this relationship that we believe we see in the data is due to the actual, 49% of the data, 49% of the data is explained by the relationship between the mean age of the chief and the mean age of the members. And the other 51% is due to residual factors. All right. As far as this goes, r equals 0.70. What kind of correlation is that? Well, that's at the top end of the moderate, so that's a moderate correlation. So we have a moderate correlation, but is it significant? Is it statistically significant? That we have to test. So I'm going to do the hypothesis test on this, and our formula for a t-score is on the bottom of page 441. So t-star, the calculated t-score would be R 0.70 divided by the square root of 1 minus r squared, 0.49, over n minus 2 would be 7, because n was equal to 9. There were 9 pairs of data, so n minus 2. The degrees of freedom are 7. So let me just notate that somewhere. N equals to 9, degrees of freedom is 7. All right, so we're going to see if this correlation is significant. And so, excuse me here while I punch this stuff in my calculator. All right, well, I hope I did that right. I've got a t-score of 2.59, which looks like it's probably significant. Let's go to the chart, page 650, and we're looking at 7 degrees of freedom, so that's kind of near the top here, and I'm looking for 2.59. So 2.59, if you look at the lines for 7 degrees of freedom, along that line, 2.59 lies between 2.36 and 3.00. And when you go up to look at probabilities, it means it's less than 0.025. So the p-value is less than 0.025. All right, so does that mean our correlation is significant? Yes, it is. You know, a very small sample. Think about it, a very small sample, but we have enough evidence here to conclude that with a p-value less than 0.025, you know, greater than 97.5% confidence, that the correlation, the moderate correlation, is statistically significant. 49% of this data is explained by the relationship between the mean age of members and the mean age of the chief. So we do have a legitimate correlation here, and so that determines that the relationship is in fact significant. So anyway, I thought that was a pretty interesting problem.